Welcome to Projects M Squared and M Cube, Written Communication in Mathematics. Mathematical thinking and learning are deepened and enhanced by activities in which students and teachers talk, write, and use mathematical symbols together while working hard to convey and clarify their mathematical ideas. This webinar addresses written communication, an integral part of both mentoring young mathematicians and mentoring mathematical minds. My name is Valerie Josie. I have 31 years in the public school system, 21 years as an elementary classroom teacher. After that, I served in the curriculum office as a math coach, as the professional development school facilitator working with pre-service teachers and with first-year teachers, and as the elementary math coordinator. I began working with Project M Squared, a primary mathematics program in 2008, and the move to include Project M Cube was a natural fit. Both M Squared and M Cube were written and developed by some of the same authors, with basically the same goals and strategies used in both programs. Since my retirement from the public school system in the state of Texas, I have worked as an elementary math consultant, sharing what I have learned about teaching math in programs that include all of the best practices and make math something real and fun for both children and teacher. Since children learn to talk before they begin writing, it is recommended that you view the webinar on verbal communication before this one on written communication. As a student, I never did much writing in my mathematics classes. It was pretty much solving problems and writing numbers down. Labeling answers was the writing. So now why do we want students to write? Written communication comes in many forms, such as words, drawings, and numbers. Writing is one of the vehicles that advance student understanding through reflection of one's own and others' ideas. When students reflect on what they have learned and write about it, they are working and acting like practicing mathematicians when they do this. Writing in mathematics encourages creativity, exploration, and communicating with one's thoughts and feelings. Students must organize their thinking, use key vocabulary terms and phrases, and communicate mathematically, which leads to deep and meaningful understanding. Additionally, writing in mathematics helps students make connections to real-life applications of the math that they're learning. Teachers can use students' writing to assess their learning. When you can read what a student is thinking, you can see how they understand a topic and where their strengths and weaknesses are. The teacher can also assess each student's attitude toward learning mathematics and focus instruction accordingly. Perhaps most importantly, when students are learning to write in math, they are writing in order to learn mathematical concepts. It's a circular process. Now that you can see the importance of written communication in the math classroom, let's look at how projects M Squared and M Cube are structured to help promote students acting like real mathematicians. Research has found that curriculum designed to provide experiences where students actually apply the methods utilized by the professional to an interesting problem helps students understand the concepts of the discipline more deeply and make connections within and across disciplines more easily. Our agenda covers both Project M Squared, designed for kindergarten through grade 2 students, and Project M Cube for mathematically talented students in grades 3 through 6. We'll begin by looking at transitioning between verbal communication to written communication through the use of the talk frame used in Project M Squared or the math messaging board in Project M Cube. We'll briefly explore using a word wall in math and follow that with the writer's role and tips for writing. Next, we'll delve into Think Deeplies, questions that address the essence of the lesson. We'll look at the phases of writing in math class as it pertains to the Think Deeplies. Lastly, we'll close this webinar by exploring tools which help assess students' writing. So, let's get started. There are 4 types of mathematical writing. Exploratory writing is writing that helps students make sense of a problem or situation and sort through their own thoughts about mathematical concepts. Such writing can be initiated by the student at any time. It may be used more frequently when beginning a mathematical task as a way to brainstorm a problem's possible solution, ask questions, or work out confusions. Informative or explanatory writing positions students to describe and explain mathematical ideas. This kind of writing is a good opportunity for teachers to remind students that they should be clear in their writing and to guide students so their written messages are mathematically accurate. Students can be asked to write descriptions of mathematical concepts, representations, and definitions. They may be invited to provide mathematical explanations, explanations for solving a problem, writing about mathematical connections, and making comparisons between different representations or comparisons to real-world applications of math. Students may use this type of writing to communicate to others, such as their teachers or peers. Argumentative writing is writing in which learners construct viable arguments and critique the arguments of others. They clearly state their position and back it with evidence. In addition to justifying their own positions, students read, analyze, and evaluate the mathematical arguments of others, taking the opportunity to either strengthen a peer's argument or disagree with it while providing their own evidence or counterexamples. In mathematically creative writing, students think creatively and document mathematical ideas that extend beyond the intended outcome or process of solving a problem. A student may generate original ideas, pose novel problems or questions, and display flexibility and fluency in ideas. Writing down outside-the-box ideas in this manner is something mathematicians do regularly. All of these types of writing are embedded in both mentoring young mathematicians and in mentoring mathematical minds. It can be challenging for both teachers and students to keep track of all that has been said during a discussion. Teachers using the Project M² units use a talk frame to keep track of student contributions and revisions to their ideas. The talk frame is a system that helps teachers organize and maintain a more permanent record of the conversation on the board. A talk frame consists of 3 parts: think, talk ideas, and we understand. Think establishes the topic. When using the talk frame with the Think Deeply question, I have students restate the question in their own words. Talk ideas are brief statements of students' ideas. Both correct and incorrect ideas are recorded. These ideas may be refined as students discuss and clarify their ideas. This is an opportunity to gather different student perspectives. We understand? In this section, the teacher guides students to reach a mathematical understanding. Students often notice the errors in their thinking, given time to discuss and justify their ideas. The talk frame becomes the bridge from verbal to written communication. This is the Think Deeply from the introductory lesson in the Level 1 book, Exploring Shape Games, Geometry with Emmy and Zany. I want to win my lingo game. I rolled a 4. Write an X to show me where to put my next chip. Why should I put it there? And the student is to respond by telling Zany where to put their chip and why to put it there. As you can see, students are writing an explanation to Zany. The use of characters in the Project M² series motivates students to write as they want to tell the characters what they think or what they know. This is an example of a talk frame constructed during a class discussion when presented with the preceding Think Deeply question. See how the completed talk frame helps support student writing. Much like the talk frame in Project M Squared, the math messaging board is the connection between verbal communication and written communication in Project M Cube. Using the math messaging board, teachers record conversations, especially those that center on the important mathematical ideas of the lesson. Since students are expected to write about these ideas, documenting the conversation helps solidify student understanding. The math messaging board consists of 4 parts: talk about it, keep a record, wrap it up, and write about it. Talk about it is what the class will discuss. Here again, students restate the question in their own words. Keep a record is where each new idea that students bring up in the discussion is written down as bullet points. This section is meant to be notes that give students a reference point to begin writing their Think Deeply responses. Wrap it up signals a discussion that encourages consensus and mathematical understanding. Write about it. It's now time for students to write their Think Deeply responses in the Student Mathematician's Journal. This is the final link connecting the talking and the writing. This is a Think Deeply question from the Level 4-5 unit, the 10th Street Pet Sanctuary, Understanding and Using Decimals. Jack and Campbell were playing the Happy Parrots game. Jack had shaded in 1 75/100 and Campbell had 1 99/100 shaded in. The card that Jack drew had him add 7/100 plus 4/10 and 1 whole. Campbell drew a card that had her add 1 whole and 17/100. A. Who is ahead now? B. What is the difference in their scores? And C. Explain how you know. Here is an example of the math messaging board constructed during the class discussion of the preceding Think Deeply question. The question has been simplified and shows the student understands it. A student will use the points recorded in Keep a Record when writing his or her response and end with the solution shown in Wrap It Up. Like the talk frame, the math messaging board serves as a guide to support student writing. A math word wall encourages and strengthens correct mathematical vocabulary for both verbal and written communication. When writing, a student may sit for 10 minutes with his hand up, waiting for the teacher to spell a word correctly for him. With the word wall, the student can locate the word and write it for himself. The yellow cards are from Project M Squared. One card shows the mathematical term, and the matching card shows an illustration of the term. The vocabulary cards for Project M Cube show the term on one card and a definition on the matching card. I like to have students illustrate the word to show they understand the definition. These cards can be used interactively to reinforce correct mathematical vocabulary. Of course, students could match up each pair, or given the definition or picture, they could identify the word. Given the word, illustrations could be drawn and posted on sticky notes. Since math has a language of its own, the list of vocabulary words can be quite extensive. My recommendation is to display the vocabulary cards for the current unit. Remove them when you move on to a new unit and put up the cards for the new unit. Otherwise, you will wind up with a math word wallpaper and it will lose its focus. The writer's roles in the Project M Squared program are designed to help students understand how to approach their writing and ways they can communicate their ideas. It will take time for students to understand how to write in math class. Most students and teachers learn to write through a language arts lens. There are some different conventions when we write, like practicing mathematicians. Young student mathematicians are developing their general writing skills. Before students write, they need to break down the question to make sure they understand what is being asked. Then have an opportunity to talk out their ideas, which may include drawings and or possibly using manipulatives. The key component of sound mathematical writing entails justifying the ideas. Mathematicians Write On is the M-Cube companion piece to the Writer's Roll scroll in Project M Squared. Mathematicians Write On offers some guidelines to encourage thorough responses. These include making sure students read and understand the question, brainstorm ideas, write their preliminary responses, read over their responses to make sure they answered the question and defend their ideas, and revise their responses if necessary. Now that you see all the support for writing, let's look at the piece where students do most of their writing in Project M Squared and Project M Cube, the Think Deeply's. Each lesson contains a Think Deeply question. There is one question in every lesson in Mentoring Young Mathematicians and two in every lesson in Mentoring Mathematical Minds. These questions focus on the important ideas of the lesson and are intended to have students think deeply about the mathematics and grapple with difficult concepts. They are the heart and soul of the lesson, and considerable time and attention should be devoted to working with the Think Deeply's. The questions increase the depth and complexity of the mathematical concepts, thus challenging talented students to move beyond the obvious and delve into sophisticated mathematics. The questions provide challenge, promote creativity, and demand critical thinking, all hallmarks of a solid math program for talented students. So, what are characteristics of quality writing in mathematics? What are the goals we hope to see students achieve in their writing? Of course, first, they must understand the question. I have found that having students restate the question in their own words indicates whether they have that understanding or not. In a piece of quality writing, the writing clearly communicates the writer's thoughts. This is evidenced by thoughtful organization so that the writing flows smoothly. Writing is in complete sentences, and mathematical vocabulary is used appropriately and correctly. Another characteristic of quality writing is that ideas are effectively defended. All parts of the question are answered and the solution is solidly justified. Reasoning is supported with numbers, tables, drawings, charts, graphs, diagrams, examples, equations, and possibly other representations. More than one solution strategy may support the reasoning. Also, connections may be made to prior learning and generalizations. So, what does this look like? We'll begin by looking at some Project M Squared Think Deeply's. In the kindergarten unit, Sizing Up the Lilypad Space Station, Measuring with the Frogonauts, students are to identify the correct way to measure length and write about what is wrong about two of the ways illustrated. Fonzie's confused. He measured and got different answers. This is what he did. And then you have the illustrations. Students are to circle the right way to measure and then explain why two of the others are wrong. Unfortunately, I don't have a sample of a kindergartner's response to this Think Deeply, but here's an example of a kindergartner's writing. Colton was shown a cylinder, asked to identify it by name, and then write as many attributes of the shape as he could. He wrote, "It has two bases, it can stack, it can roll, it has no sides, it has no corners, it has a circle base." Not bad for a kindergartner. Here's a sample of a Grade 1 Think Deeply and response. This is from Creating the School Measurement Fair, Measuring with Emmy and Zany. Please help us figure out when someone wins. Show us one way the scale can look. Tell us what people can say to win. Sebastian drew a picture of a hanger balance, showing the bag with a square lower than the bag with a circle. In his letter to Emmy and Zany, he wrote, The circle bag is lighter than the square bag. The square is heavier than the circle. The square is down and the circle is up. Our grade 2 sample, Think Deeply, comes from designing a shape gallery, geometry with the Meerkats. Students used straws to build a frame of a cube and dipped it in a bubble solution. Drew says she saw a cube inside the dipping frame. Teller says he saw a square. Students must tell the difference between a cube and a square. Here's Kelvin's response. Dear Drew and Teller, the cube has 6 faces and they are squares. See? And then he has a picture of a cube. It sticks out and is 3D. A square is just a square. It does not have faces. It has 4 sides. And then there's a picture of a square and he's numbered the sides 1, 2, 3, and 4. Your friend, Kelvin. We'll look at some Think Deeply responses from Project M-Cube in just a bit. But right now, you're probably wondering, how do you get students to write in mathematics? It doesn't just happen. Kindergartners develop their writing abilities at different rates, so their writing will include more representations. The sophistication of their ability to communicate on paper will also range from student to student. The talk frame is used along with each Think Deeply question to help students connect their verbal thinking out loud with their developing communication. Modeling student thinking on the talk frame helps kindergartners see how words can support and explain the ideas in their representations, such as drawings. While it is important that students write in a way that feels natural to them, they also need to be introduced to the characteristics of mathematical writing. This may include justification through words or other representations. To help students come to better understand mathematical writing, Think Deeply questions are scaffolded throughout the units, beginning with teacher guidance and ending with more student independence. The long-term goal is to have students become proficient math writers. The model describes how the writing is structured in the Project M² grades 1 and 2 units. Each unit begins with providing models of good math writing for students. Notice the progression from the group writing to partner writing to individual writing, and also how students participate in providing feedback about others' writing. Please note that some students will need additional support during the individual writing phase, while others will be able to work more independently. While structure is provided throughout the units, teachers are highly encouraged to make adjustments depending on student needs and comfort with the writing process. It is important to differentiate and make adjustments based on individual student needs. Now that you're familiar with Think Deeply's and the phases of writing, as teachers we all want to know, where are the answers? Remember the sample of the Grade 1 Think Deeply, the one that shows Sebastian's response? It is in the teacher guide where it would be used in the unit. Following each Think Deeply question is a section titled What to Look for in Responses. This section has bulleted points that list what should be covered in students' responses. It is not necessary that every bullet be included in the student's response, but enough that all parts of the question are addressed correctly. Following this part is a section called Possible Difficulties. Here, possible misconceptions students may have are listed along with suggestions to help correct their thinking. It is important for students to receive guidance from the teacher, not just from their peers. The unit lessons progress from the teacher providing oral feedback to individual written feedback. The Think Deeply Feedback Teacher Guide is designed to help teachers have a better understanding of what to look for in students' responses. The purpose of the feedback is to identify strengths and challenges, to foster positive attitudes by acknowledging work attempts, to help students reflect more on their work, to promote clarity in writing, and to move student understanding forward. The Think Deeply feedback can be used by teachers and possibly by peers in their critique of student writing to help guide them in providing positive and productive feedback. Much as there are phases for writing in Project M Squared, Project M Cubed also has phases of writing, and they're quite similar to those. Since the idea of writing in math class may be new to most students, it is important that you guide students' development to express their thinking in writing. Students should examine a model of an exemplar writing piece right from the start. Encourage students to identify what makes the model an exemplar. Was it appropriate vocabulary used throughout the response? Did the example used help clarify the argument? Were many details used to explain the reasoning? Did a table or a chart more effectively communicate an idea? After analyzing an exemplar, write a response as a class. As a next step, encourage students to write with a partner. Discussion between partners provides direction to students. Peer critiquing can be an effective tool in math class. By providing examples that need work and having a class discussion on how to improve them helps students in their own writing. The ultimate goal is for students to be able to write on their own. Peer editing, as well as constructive feedback from the teacher, is helpful at this stage. Giving students focused feedback or asking specific questions regarding their responses will help students to clarify or change what they've written. Just telling a student he did good doesn't give him much feedback. Exactly what parts were good? What did he do good with? Or if you're saying it needs work, where does it need work? What kind of work do I need to do to make this better? Learning how to write an effective response is a long-term process and should be addressed continuously as students become more proficient writers in mathematics. Just like in Project M Squared, Project M Cubed provides what to look for in responses and possible difficulties after each Think Deeply question. In addition to that is a scoring rubric with 3 areas of consideration in assessing writing: understanding mathematical concepts, expressing mathematical reasoning, and using appropriate mathematical language. The rubric uses a 4-point scale where 4 represents all the time, 3 most of the time, 2 some of the time, and 1 little or none of the time. We'll look at applying this rubric to samples of students' responses to Project M Cubed Think Deeply's in various levels. Then we'll also look at some sample teacher feedback. This is a Think Deeply question from the Level 3-4 unit, How Big is Big? Understanding and Using Large Numbers. The Think Deeply reads, Sasha's challenge card read, multiply to include all the members in your family. She has 4 people in her family, and her trip was 6,997 miles, so she rounded the number to 7,000 and multiplied by 4 and got 28,000. She thought, now all I have to do is subtract 3 to get my answer. Part A of the question, do you agree or disagree with her reasoning? Why? And Part B, find the total mileage. Here's this student's response. I disagree with Sasha because she should not have subtracted just 3 to get her answer. So what she should have done was subtract 12 from 28,000. The total mileage is 27,988. The reason Sasha should have subtracted 12 is because if she subtracted 3, she would have only done one member of her family. What she should have done was subtracted 3 from each 7,000. And in the bubble, the child put 6,997 rounded to 7,000 times 4 equals 28,000 minus 3 equals wrong. 28,000 minus 12 equals correct, which is 27,988. Now let's look at the first section of the rubric, Mathematical Concepts. This section is scored using these considerations. How well does the student understand the concepts? Was an appropriate and efficient strategy used to solve the problem? Were all parts of the question answered? Here's the Think Deeply again. Thinking about mathematical concepts. This response shows that the student understands that 6,997 was rounded to 7,000 and that subtracting 3 would only have accounted for one member of the family. The student knows that 12 must be subtracted from 28,000 since there were 4 members, and includes the correct final answer of 27,988. The score for mathematical concepts is a 4. The rubric states that for 4, overall, student demonstrates a strong understanding of concepts and, if applicable, uses an appropriate and efficient strategy to solve problem correctly. The student answers all parts of the question or prompt. Let's go to the next topic, mathematical reasoning. In scoring mathematical reasoning, consider these factors. Does the student state well-developed ideas or generalizations and build a strong logical progression of statements to explain the reasoning? Is the conclusion fully justified with supporting details? If appropriate, are representations such as examples, charts, graphs, models, and words used? This time, the Think Deeply question is from the Level 4-5 unit at the Mall with Algebra, working with variables and equations. Here's the Think Deeply. Here's an equation, 7 plus 2x equals 9. A. Explain 2 different ways to determine the value of x. B. What is the value of x? And C. Which method do you think is better? Why? And the student's response. 1. First you cover up the 2 and x. Then you think, what plus 7 equals 9? The answer is 2. Then you think, what would work for x? 2 times 1 equals 2. 2 plus 7 equals 9, so x equals 1. And there's your answer. And the second part, the backwards method changes the signs, so plus is a minus and times is divide. You would do 9 minus 7 equals 2. So x equals 1 again. And then the student says, I prefer the backward method because it's easier for me. How would you score this for mathematical reasoning? Did you notice that the student describes most of the steps taken for each method? They needed to elaborate more on how the value of x was determined using the working backwards method. The score for mathematical reasoning is a 3. On the rubric, 3 states, the student states adequately developed ideas or generalizations and builds an appropriate logical progression of statements to explain the reasoning. The reader may need to infer a step that has not been fully explained. The student provides some justification for the reasoning. The final area for scoring is mathematical vocabulary. Consider these 2 questions when scoring. Does the student use all mathematical vocabulary appropriately? Did the student include mathematical vocabulary related to the major math concepts of the unit? The Think Deeply question is from the Level 5-6 unit, Designer Boxes, Exploring Volume and Surface Area. And the Think Deeply reads, what is volume? How can you find the volume of a rectangular box? Does your method work to find the volume of all rectangular boxes? Why or why not? The student response. I would find volume by multiplying the length and width to find the volume of one layer and then multiplying the height and our previous number, the length times width product. This will get you the volume of your prism. My method works for all even rectangular prisms that are even because each prism has height, length, and width. And then as an afterthought, the student wrote, volume is the amount of space inside a three-dimensional 3D object. What score would you give this student on mathematical vocabulary? In this Think Deeply, the student uses the terms length, width, height, rectangular prism, and volume correctly. So the score for mathematical language is a 4. For a 4 in mathematical language, the rubric reads, the student uses all mathematical vocabulary appropriately, including mathematical vocabulary related to the major math concepts of the unit. As teachers, you are helping develop young mathematicians, and they should be learning how to think, speak, and write using the language of mathematics. Providing written feedback to students is essential in helping them to develop these skills. Written comments should be substantive and relate to the scoring using the rubric. Students need to understand why they received a particular score. Provide helpful hints to improve their writing by adding on to or editing the work they've done. This process is a means of informal assessment and is not recommended as a formal grade or assessment for every Think Deeply. Doing so may stifle student creativity and risk-taking in their mathematical thinking. Remember the Level 3-4 Think Deeply? It's quite thorough and received all scores of 4. Here's the teacher feedback. Wow, you definitely understand what Sasha did wrong and gave a clear and logical explanation. Can you now answer Think Deeply number 2? The Level 4-5 algebra example scored a 4 on mathematical concepts, a 3 on mathematical reasoning, and a 2 on mathematical language. Here's the teacher feedback. Great! I see how you used both the cover-up and working backwards methods to solve the equations. You say that you prefer the working backwards method because it is easier for you. Tell me more about this. I wonder why you decided to change from addition to subtraction to solve this problem. What mathematical words can you use to describe what you mean? I also would like to hear more about how you determined the value of x using the working backwards strategy. The final example is the volume question from a Level 5-6 Think Deeply. This response scored a 3 on mathematical concepts, a 3 on mathematical reasoning, and a 4 on mathematical language. The teacher feedback reads, you have used excellent vocabulary. Your method to find the volume of a box works, but explain why. Also, what units do we use to measure volume? Finally, what do you mean by even rectangular prisms? The purpose of writing in mathematics is to help students better understand the concepts. Both the talk frame and the math messaging board are a written record of the ideas discussed and clarified in a class conversation. Students can use this record as a reference point when writing their responses to Think Deeply's. Another way to support student writing, particularly in the lower grades, is by having a writing center. The Writing Center is a special place in the room where students have multiple tools available to facilitate the communication of their thoughts. It should be an inviting place and one that students can easily access so they can express their ideas. And the last is just a reminder of the importance of teacher feedback. We looked at written feedback from the teacher from grades 2 and up. But in the lower grades, the teacher should provide an opportunity to conference with individual students. Let the student know what he or she has done well, what the student needs to further develop, and what the student should focus on next. Remember, writing is a process, and it develops with time, practice, and thoughtful guidance. To wrap up written communication, let's look at a short video from Mentoring Young Mathematicians and funded by the National Science Foundation.
Writing is a unique way the Project M Squared units engage the student mathematicians. Students are encouraged to write on a regular basis and answer Think Deeply questions about significant mathematical ideas.
So you said, can you read it back to me, that you said
A is wrong.
Can I put right, please?
because,
It has gaps.
Dr. Costa,
so he
can I
needs
put
to make
right?
sure that they're like this. I
Dr.
think you
Costa,
explained it to him. Nice job.
As part of M Squared, the Think Deeply questions require the students to be able to write about the mathematical concepts they're learning. Those students are writing much more, and I'm finding that it fits the Common Core standards of writing outside of language arts, and our students are feeling more confident about it each year that we do this program. So the writing piece has made me very excited because we weren't very good at that when we started.
In this Think Deeply question from the Grade 2 Geometry unit, a student contrasts the attributes of shapes. She writes,
The difference between a cube is that a square has 4 sides and a cube has 12 edges. And that you can put something in a cube and nothing in a square. A cube has 6 faces and a square has 1 face. A square is 2D and a cube is 3D. A square is flat and a cube is not. A cube is held in your hand and a square can be pinched.
we provide many supports so even our youngest writers can succeed in expressing their ideas. Students use an interactive word wall to bolster their use of mathematical vocabulary. The talk frame models for students how verbal ideas can be recorded in writing.
Oh, okay. Okay, he can turn right. I'm going to underline that word, right? Or left.
Writing in the Project M Squared units in kindergarten can definitely be overwhelming. It can set off a little anxiety as a beginning of the year. How can I get a kindergartner to write these ideas? And I think that the activities that M Squared sets up prior to the writing gives the students so much knowledge, and they're so comfortable and they're so excited about what they know that when they sit down to write to the Frogonauts, to Frida and to Farley, and to tell them what they know, they want to do it. They were eager to share their ideas.
For more information on Project M Square, you may wish to check the website projectm2.org. And for Project M Cube, the website is projectm3.org.